Hello and welcome to this tutorial video. Today we did a model of the pullout test here of a, let me show you, of a ceramic. See, this is a ceramic nail or something like a screw, but it's called nail, ceramic nail from the bone here. See, this part is a bone and here this is the ceramic nail. Uh, this ceramic nail recently uses in the medical surgery to make a joint between two separated bones. So here we did the direct pull-out. For instance, we uh, put load on the top nodes of the ceramic nail, then the pull-out happened. But here you can see the view cut. We use frictional contact, the friction and the frictional behavior contact between the bone and the ceramic nail, and you can see here during the pull-out test, see this ceramic nail is failed in some area in the frictional test. Let me click here on this to check the stress. This is the stress for ceramic, the stress wave propagation under the pullout test. These are the damages zone here. This is the brittle material. We used some material data and we make combination between them. For instance, shear modulus, equation of a state, damage, plasticity, everything to consider the brittle failure of the uh, here of the ceramic nail. Let me replace the bone. Here, this is the bone. You can see the stress in the bone. Also, you can check the damage for it. See the damage happened here. And also the damage for the nail. You can see the damage here. Okay, or anything else. In the second model, we use ideal contacts between the nail and you can see in the ideal contact a little bit different. We have a little bit differences between the ideal contact and frictional contact or behavior. If I click on animate here, you can see that the stress propagation and the damages which happen all here, and you can see here, and it is failed completely. See that? You can also use rotation for this to do the pull-out test. And now let me check the damage for the bone. And this is the damage for the bone here. It is much more than the previous model that we used frictional behavior here, the damage. And we can also get any result that we want. For instance, for the force displacement, we have two diagrams. See, this is the frictional, the red, and the blue is the ideal contact. You can see the behavior is the same in the peak and minimum of the force, but here in the perfect contact or ideal contact, we have a force capacity a little bit more, but in the frictional behavior a little bit less, around 10 to 15% differences happen between two methods. Also, we can use cohesive interaction. We can neglect this threaded here, these edges here, and we can use a flat nail, and we can use cohesive interaction between them, but it is more realistic than that. You can see we can have the engagement here. See the engagement, for instance, the damage of the nail and bone. If we click here again, you can see after the load we have the engagement of the surfaces, then the failure happen and the damage. After that you can see. So if you need this tutorial of the pull-out test of this ceramic nail, you can come to our website here. The website abaqusfem.com. Find the English tutorial here. This is the English tutorial. You need just read the tutorial with the English title. We have another language also. You should use English one. So click on title or blue sign, then you will have this title, part, assembly, material, step interaction, load, and then the result as figured for both model. You can provide CAE, INP, and English video file of this simulation, and after that, if you need any help, we will be available to respond or answer your questions. You can use a PayPal account, a Visa or MasterCard for the payment. Before that, contact me to this email. Okay, and we have also a full package here. This is the another option. The full package of the website contains around more than 400 tutorials from the beginner to advanced, and it is about anything that you imagine. For instance, we have explosion. So explosion with which method? All method, couple Eulerian Lagrangian, osmose, particle hydrodynamic, acoustic, convex, pure Lagrangian for any materials, impact low and high, welding for all method, biomechanics, forming crack, and anything that you think. So the cost for this package is so affordable for all people, engineer, student, I don't know, PhD student, and you can buy that easily. Just contact me to this email to tell you about the purchasing process, and you can have this package, this full package, for a good price. So if you have any questions, contact me to this email and I will answer your question. Thank you for your attention.